To make the management experience better for a classroom-specific scenario, we came up with Intune for Education. So Intune for Education is a cloud-based console, but takes some management use cases from Endpoint Manager, which are common in education, and makes them more easily discoverable, makes them quicker to configure, and really simpler compared to Endpoint Manager. So the idea behind Intune for Education is to provide an easy-to-use interface that can be used by anyone. So not just IT pros. And this intuitive interface, by using this intuitive interface, you can easily manage school devices really in no time. You can manage Windows devices and iPads. But today, I'm going to focus on Microsoft Endpoint Manager, as I say. And Microsoft Endpoint Manager is our cloud solution for managing cross-platform devices. So by using Endpoint Manager, we can manage Windows, we can manage iOS, macOS, and Android with a very high control degree, covering the entire device management life cycle, starting from the enrollment, moving into device settings configuration, application deployment, reporting, device inventory, up until you decide to replace your devices at the end of the life by simply retiring them. And so this is what is called mobile device management. But Endpoint Manager offers also the capability you might need for scenario where you might want to manage personal devices in school. And for this scenario, we can leave the device unmanaged, but provide still secure access to our applications like Microsoft 365 apps using what is called mobile application management. Two important things to note. The first one is that Microsoft Endpoint Manager and Intune for Education, they both use the same underlying service, which is Intune. So we have two different consoles, one more meant for IT pros and the other one more tailored for school administrators. But again, they use the same underlying service. And the last important thing to note is that you don't need two separate licenses. So one license entitles you to use both consoles. Now let's see how we can manage settings by using Endpoint Manager. So settings allows you to define the configuration of your devices and how the students and teachers will be using those devices in schools. Settings are assigned or can be assigned to users and devices using groups. Settings that you assign to users in a group will be applied to all devices the users in the group will sign into, while settings applied to devices in the group will be applied to all devices that are member of the group that you targeted, no matter who will be signing into these devices. Now let's focus on the settings catalog. So by using the settings catalog, you can easily customize, set, and manage devices and user policy settings. The settings picker allows you to search or browse to select any settings available in the settings catalog. And for Windows, the settings are directly generated from the Windows configuration service provider, so the a CSP for Windows, which is a document that defines how you can configure setting on a device. And the settings experience is generated dynamically based on the type of settings and the metadata that comes from this Windows configuration service provider. So this technology also enables us to quickly add new Windows settings and reduce the need to deploy custom policy. which I will talk to you in a bit. As of now, you can create policies using the settings catalog for Windows, iOS, and macOS, and Android will be supported at a later time. When creating policies in the settings catalog, you can also apply filters to narrow down the settings that you want to be shown while you are searching them. And the settings catalog offers also a summary report where you can see an aggregated view of your policy state and also the properties of the policy that you have deployed. And there is also a detailed report that shows you detailed information like the device name, the policy status, and additional information. You can also filter the deployment on the deployment status. So if you go to the report and go to the deployment status, you can filter and export the view to a CSV file. I briefly touched before custom policy. So Intune or Endpoint Manager includes many built-in settings that control different features on a device. But not all settings that you can configure on a device are available in the Microsoft Endpoint Manager UI. So what can you do when you want to configure one of those settings that are not exposed in the UI? The answer is creating custom policy. So you can create a custom policy, and this is probably the most advanced, the most complex administrative task you can be required to do in Endpoint Manager. So on Android and Windows, when you create a custom policy, you are going to use what is called the OMADM protocol, which is a standard vendor-independent protocol. While on Android Enterprise, you can also, additionally, you can also use OEM config, and this one is instead a Google standard. And finally, to configure settings that are not exposed for Apple devices, you can use Apple Configurator or Apple Profile Manager. However, as I said before, with the settings catalog, we are going to really drastically reduce the need to create custom policies. Now I'll show you the new settings catalog and how this can be used to assign settings to your devices. Let me move into the Endpoint Manager Admin Center. So this is the Endpoint Manager Admin Center. As you can see here at the home, we have a dashboard that shows you the status of the tenant. It provides you a summary of any eventual error or failures, the LT state of your devices. And here we have some additional indicators that shows you the status of your tenant and your devices. So to create a policy by using the settings catalog, I'm going to go to devices and then configuration profiles. I'm going to select create. And for this workflow, I'm going to select Windows 10 and later. And as a profile type, I'm going to select the setting catalog. So before I select the settings catalog, I wanted to show you, I wanted to explain a bit why we have two different options. So the first one, which is what we are going to do now, is the settings catalog. But we have also here templates. And templates is the name that we gave to group all the settings that we initially made available on Endpoint Manager. Those settings are also referred internally as to DCV1, which stands for Device Configuration Version 1, as opposed to the settings catalog policies that are also referred as DCV2 or Device Configuration Version 2. We do recommend definitely using the settings catalog unless you need to create policies for Android, which is, as I said, not supported until we will be migrating all the policies to the DC version 2, which in turn will allow you to create Android policies for Android devices using the settings catalog. So I'm going to select settings catalog and hit next. I'm going to give it a name, workshop Windows settings. Select next. As you can see, when you initially create a settings catalog policy, there is no settings that gets pre-populated. So if you had some experience by using templates where you have, depending on the template, all the different categories of policies, there is nothing in the settings catalog. So I'm going to hit add settings. And sorry, in the settings speaker, so by using the settings speaker, you can search or browse to select any setting that is available in the settings catalog. So for example, I'm going to select connectivity. As soon as I select one of the settings category, connectivity in this case, this is going to show me what are the settings available for this specific category. I can also add a filter. For example, I want the setting picker to show me just a specific operating system edition. Like, let's select education and enterprise, for example, or just education. I think in this case, it won't show me anything, but just to show you that this will apply a filter based on the operating system that I've used with a filter. So I'm going to remove it. I'm going to select connectivity again, and I'm going to pick a couple of them. And as you can see, within the configuration settings part, the settings will be added. One important thing to note is that settings that are not configured with the settings catalog are configured as, are set as not configured. This means that whenever I set a setting, a property, for example, allow connected device to set to allow, and I'm going to apply this policy to a group of devices. Whenever I go back and change the policy and remove the setting will not only be removed from the policy, but it will also revert the setting back to the default value. I have also tooltips that explains you what the setting, what are the setting, what is the specific effect for the setting that I've selected. And I have also a link to the documentation. I can remove and eventually bring the setting back. So I'm going to select next. And I'm going to assign it to all my devices in this case. All right. So the policy using the settings catalog has been created. Here you can find some useful resources if you want to learn more about device settings management in Microsoft Endpoint Manager. Now I'll move into applications management. Microsoft Endpoint Manager supports different types of applications. We support store apps for all platforms. We support web apps, which are shortcuts to a website and can be deployed on Windows devices by creating an icon on the start menu, and to iPads by creating an icon on the home screen. Android system apps are supported on Android enterprise devices, and you can enable Android system apps for Android enterprise dedicated devices, as well as fully managed, corporate owned with work profile, and personally owned with work profile as well. You can use built-in apps, and the built-in app experience makes it easy for you to assign managed apps. For example, you can deploy Microsoft 365 apps or third-party apps to iPads and to Android devices. You can assign specific apps for this app type. For example, in the case of, again, Microsoft 365 apps, you can deploy Excel, OneDrive, Outlook, and others applications which are part of Microsoft 365. Then you can deploy line of business apps, which are the ones that you add from an app installation file. And this kind of app is typically in-house written apps. And they can be in the form of MSI, Apex, depending on the platforms. So for iOS can be IPA, APK, and so on and so forth. Then you can deploy macOS DMG apps, and essentially a DMG is a disk image file that contains one or more applications, and many common applications for macOS are available in the DMG format. And the last one is Win32 apps, which I'm going to talk about in a bit. So to extend the device and the application management capabilities beyond what's available using the device management APIs, because what we have just seen is leveraging the device management APIs onto the different platforms. You can run scripts. So if you want to extend these capabilities, you can run scripts on your devices. You can create a shell script to run on macOS devices, or a PowerShell script to run on Windows 10 and Windows 11 devices. For example, you can create a script that does some advanced configuration. So what you do is to create your own script, upload it to Intune, assign the script to an Azure Active Directory security group, and let the script run. The nice thing is that you can monitor the run of the script, the run status of the script from start to finish. Now, again, as we have seen for settings, applications can be assigned to users or to devices in a group. Again, apps that will be assigned to a security group that contains users will be installed on every device the user in the group will sign into, while apps that you assign to devices in a group will be installed on those devices that are member of the group, no matter which user will be signing into those devices. Applications can be deployed as required or as available. Required or mandatory apps can be will be silently installed onto the device and doesn't require any user intervention. So they will be, again, silently installed, while available apps can also be published as available, but it's important to remind that you can target applications, you can deploy applications as available, targeting only users, not devices. So once you publish the apps as available, end users will need to take some actions. So they will need to open the company portal app and select the apps that they want to install. So essentially, the company portal app is the application catalog from which every user will install the application that you publish it as available. Of course, the company portal is used on Windows and Apple devices, while on Android, the end user will be using the managed Google Play, which is the Google's enterprise app store, and it's the only source of application for Android enterprises and Android enterprise devices in Intune. Now let's discuss Win32 applications and how you can create those. So this type of application offer great flexibility to deploy commercial apps or also in-house developed apps. Typically, you will deploy MSI and executable, but with Win32 apps, you can deploy really any kind of content to your devices. To deliver Win32 apps with the level of flexibility that it offers, we deploy an agent, and this agent is called Intune Management Extension. It is important to note that you don't need to deploy this Intune Management Extension, so the agent will get automatically installed when the first Win32 application is deployed onto the device. So the very first thing that will be done onto the device once it receives the application deployment will be installing the Intune Management Extension. With Win32 apps, you can decide whether you want to install the application in the system context or in the user context. You can determine which requirement targeted devices must meet. You can define the detection method to avoid installing apps if they are already installed on the device. You can define dependencies from other apps and update any existing apps onto the device with a new version, or also replace an existing and already installed app with a different new app by using supersedence. Now let's see how the Win32 apps works more in detail. So the first step that you have to take is to download the Win32 content preparation tool from GitHub. This tool, once you run it, will read your application content, which can be, again, an MSI, an exe, or multiple files for a complex application. This Win32 content preparation tool then generates an app manifest that will tell the app how it has, what are the files and how it has to be installed. Then it encrypts the content, compress the content, and generates a new file with the extension of .intunewin. So once you run the Win32 content preparation tool, you can start creating the Win32 app in Endpoint Manager and define the properties of the app. So let's see what these properties are. So requirement rules is the very first property that you have to define. And with this, you can define the condition or the conditions that your devices has to meet for the app to be installed. So you can define that the targeted devices must run a certain operating system version, and above that one that you defined, the free disk space that might be required, the physical memory, the CPU, and you can also define some more advanced rules using a registry key, or a folder, or actually checking for a registry key or a folder or a file, or even for very advanced scenario, you can also run a PowerShell script to do some more complex check onto the device. All those requirements are evaluated in real time, and the reason for that is to determine whether the content of the application has to be downloaded or not. Detection method can be used to verify if the application is already installed onto the targeted device. If the application is installed, then Intune won't install the application again, while if it is not detected, then Intune will start installing the application. And for this reason, it is really important to carefully define a detection rule that checks correctly the presence of the application, because otherwise we'll keep installing the application even if it's already there. We can define different detection methods. We can use the GUID of the MSI if this is a Windows installer. We can check for the existence of a file, the property of the file, including the version, the size, date, and time of creation. Or we can check the registry key and the values. Again, as for the requirement rule, you can use more complex methods by using a PowerShell script. With dependencies, we can define if the application we want to install depends on another Win32 application, and eventually install this other application as part of the deployment. With app supersedence, we can also define that the application that we are going to deploy will update or will replace an existing application, and decide eventually whether to uninstall the application that is being superseded before installing this new application. And finally, you can define the level of notification to be shown to your end users and the level of interaction that you want them to have, and to install the application at a specific date and time. Now I'm going to walk to the Win32 app creation and deployment. So I'll start downloading, as I say, the Win32 content preparation tool. We'll create the Intune Win file, and then I'll upload it to the Endpoint Manager Admin Center and start creating the application and assigning it to my users. So I'm going to move back to the Endpoint Manager Admin Center. First of all, let me download the Win32 content preparation tool that can be easily found if you Intune content prep tool. Second link is the correct one. So you select code and download as a zip file. I'm not gonna download it because I already did it in advance. So for this demo, I'm gonna use Google Chrome, which is a very popular deployment, despite we offer a great browser. And here I have Intune, the Intune WinApp util, which is one of the files that gets downloaded when you hit download on GitHub. So I'm going to run the Intune content preparation tool. Let me check where. Sorry. There it is. So I am already in the folder where the Intune content preparation tool is located. So I'm gonna type the name of the executable, and I'm gonna hit enter. So the very first information that I have to provide is the source folder. So in my case, it is in the same folder as the Intune WinUp util. Specify the setup file, which is in this case, let me delete it. This one, I'm gonna paste it. And the output folder, which is the same. Eventually, you can also specify a catalog folder. In this case, I'm gonna select N because I don't have a catalog folder. And this will, again, read the content, create the application manifest, encrypt, and compress, and then the Intune Win file has been created. So now let's move into the Endpoint Manager console. I'm going to select Apps. In this case, it is a Windows app. So I'm going to select Windows, Add, and select Windows App Win32. Hit Create. The very first thing, I'm going to select the file that I've just created, which is the Intune Win. This is going to upload the Intune Win file in the background. I'm going to provide some information about the publisher. I'm also going to select the logo. And hit Next. So as you can see, my job has been, make very simple because I'm using an MSI. So in this case, I have the install command and the uninstall command already pre-populated. I can eventually add additional switches. If it was an exe or another type of file, then I would have to provide this manually. In this case, this is going to install in the system context. So it depends on how the MSI has been created in this case. I can select the device restart behavior. I'm going to leave it with the default value, which is app install may force a device restart. And then here I have some return codes that the Win32 app, in this case, the Intune management extension, will use to read whether the app deployment was successful or not. I can also add for in-house created applications, I can create my own return codes. I'm going to hit Next. I'm going to select the operating system architecture. I'm going to select the operating system minimum version. Eventually, I can provide, as I said before, some additional requirements. I can also, as I said, check for the registry, for a registry key or a file or a script. I'm going to hit Next. So in this case, I'm going to use as the detection rule a manually configured detection rule. In this case, since I'm using an MSI, I'm gonna select it. And as you can see, the MSI product code is already populated. I'm gonna hit Next. I don't want to add any other application dependency. No supersedence, and then I'm gonna assign it to all devices. Here I can configure, as I said, the behavior of the application installation. So I'm going to hide all the notifications for the end user. I'm leaving the delivery optimization priority. Delivery optimization is a technology which is embedded in the Windows operating system that allows you to share content between devices that are placed on the same network. So this will drastically reduce the bandwidth usage. In this case, I'm going to leave it as it is. And then I'm going to install this as soon as possible with an app installation deadline, again, as soon as possible. I'm going to hit Next and then Create. And the application then will be created and installed. As you can see, initially the application is not ready because the content has to be uploaded on the service, to the service. Switching back to the slide. With this, we completed the Win32 application walkthrough. And here you can find some useful resources if you want to learn more about application management in general with Microsoft Endpoint Manager. Let's talk now about Windows Autopilot. So Windows Autopilot is essentially an evolution of the Windows deployment process. Windows Autopilot is a collection of different cloud services, different cloud technologies that enables customers to set up and pre-configure new devices to get them quickly ready for productive use. So the idea behind Windows Autopilot is to move away from the traditional processes that require the creation and the maintenance of multiple images, reimaging devices, and instead leverage the images that came directly from the OEM or from the reseller and transform them. So use the images that are shipped together with the device from the OEM or the reseller and transform them in a way that meet the needs for your devices to be ready for the classroom. Autopilot covers a wide range of use cases, starting from the traditional scenario where devices are initially joined to an on-prem Active Directory forest and later registered to Azure Active Directory, to cloud-only scenario where devices are directly joined to Azure Active Directory. Windows Autopilot also covers the shared device scenario, which is pretty common for early grades, as well as the scenario where devices are assigned directly to a specific student, or what we used to call as one-to-one. And finally, a scenario where devices are designed for single purpose, like kiosk devices. Partners and OEMs and resellers can provide additional value, for example, pre-configuring the devices with policies and applications prior to shipping them to the end users. And again, ultimately, the idea behind Windows Autopilot is to make the process for both the IT pros and for end users as simple as possible. Windows Autopilot offers two distinct, two separate enrollment options. The first option is the one that is most suitable for scenario where each student has its own, so gets assigned a specific device, or what is called the one-to-one scenario. The user-driven mode for Windows Autopilot is the one that is specifically meant for one-to-one scenario, and it supports modern cloud-only scenario where the devices are joined directly to Azure Active Directory, as well as the more traditional scenario where devices are joined to an Active Directory forest first, and then they are registered to Azure Active Directory. It supports also the migration of Windows 7 devices or Windows 8 devices you might have with Configuration Manager using what is called Autopilot for existing devices. So Autopilot for existing devices allows you to enroll and provision devices using Autopilot without having to register them in the Windows Autopilot service, injecting a JSON file which has all the information for the Windows Autopilot of the Windows Autopilot profile. And finally, it supports the pre-caching of policy and apps with what is called pre-provisioning deployment. So the second option, the second enrollment option that is commonly used for shared device scenario is Windows Autopilot self-deploying mode. This mode supports only the modern deployment method, which is joining the device to Azure Active Directory. Windows Autopilot, it's composed of the Windows Autopilot service, but it leverages also two additional services. One is Azure Active Directory, and the other one is Endpoint Manager or Intune. So Azure Active Directory provides the authentication layer, while Intune provides the deployment of policy and apps that are required for the device to be ready for productive use. Let's talk about the three main important stages that composes the Windows Autopilot deployment process. So the very first stage is the IT pros one, where all the configuration take place, like the identification of the autopilot deployment, whether this is a one-to-one or it is shared, and with the creation of the autopilot profile to define how the device setup process should work, all the policy that has to be downloaded, applied onto the device, and all the apps that have to be installed onto the device. So the second stage is where the device gets registered in the autopilot service. In this case, we are considering the scenario where an OEM or the partner or a partner is registering the device on the devices on behalf of the customer, and the OEM can use the API method, and the partner can use the partner center portal to register devices on behalf of the customer. And then the device gets registered, after they get registered, they will be shipped to the end user or to the school, depending on the provisioning methodology that you have chosen. And finally, the device are received by the student or by the teacher or by the school, depending on the provisioning method. And once they are received, they are turned on and bringing to life what the IT pro and what the OEM or the partner did to make the process simple and smooth. The enrollment status page, or ESP, this can be used to during the Windows Autopilot workflow to track the installation of applications, to track the assignment and the application of security policies, certificates, network connections. And for devices that went through the Windows Autopilot pre-provisioning process, DSP offers a very consistent user experience by ensuring that all of the required apps and policies are immediately available for users soon after they sign into their device for the first time. It also offers the ability to block users from getting to their desktop until critical applications are installed, for example, language bugs. The ESP can also be used to track application and policy with every user that signs into the device, or it can be restricted to only be shown during the out-of-the-box experience, or UBI phase. You can also define what action what actions users can perform onto the device in the event that the device setup fails. A default policy targeting all users is already configured in every tenant, but custom policies can be created, custom ESP policies can be created and targeted to both users and devices. So let's start with and see more in details the workflow for the IT Pro. So the IT Pro, the first thing that he does is to identify the scenarios of whether it is shared, one-to-one or kiosk, if the device has to be joined to Azure Active Directory, or if it has to be joined to the Active Directory forest initially and then registered to Azure Active Directory, what should be the experience for the end user during UPI, if the device must be configured at the first sign-in by pre-assigning the device in the case of Windows Autopilot pre-provisioning mode, if the device must meet hardware requirements in the case, for example, of Windows Autopilot pre-provisioning or self-deployment, where there are specific requirements that the devices must meet, whether the user should be a local administrator or should be a standard user. Once all those information are acquired and are well known by the IT Pro, it can start creating the Autopilot service and then configure all the policy and all the apps. So now let's see how an IT Pro can create the Windows Autopilot profile in the Endpoint Manager console. So the first thing I'm going to do is to create a security group. So I'm going to give it a name and call it Workshop Autopilot Workshop. The type of membership will be dynamic device. So I'm going to add a dynamic membership rule. I'm going to hit Edit. So you can create different rules. So if we move into the document that explains how to create an Autopilot device group, as you can see, I can use eventually this rule that is gonna add all registered or devices registered in the Autopilot service to the security group, or I can specify a different rule where I'm gonna check for the group tag if I want to separate devices by assigning different Autopilot profiles. Or I can also create this security group using a specific purchase order ID. In this case, it is the OEM which is registering the device on behalf of the customer, and the OEM is also assigning a specific purchase order ID. So I'm gonna, in this case, use the purchase order ID. So for my demo, I'm gonna select the one that will search for a specific scope tag. I'm gonna change this to Workshop and hit Save, and then hit Create. So the group has been created. Now that the group has been created, I'm gonna create an Autopilot profile. So I'm gonna select the devices and Windows enrollment, deployment profiles. Hit Create a profile for a Windows PC. I'm gonna give it a name, again, Workshop. So this setting allows you to target a group of devices and have them, once they are already enrolled into the Intune service, to be registered automatically in the Autopilot service for you. So this might be a useful option depending on the scenario. So I'm going to hit Next, and I'm going to define the deployment method which is in this case user-driven. I want the device to be Azure Active Directory joined. I'm gonna hide the software, the Microsoft software license terms, as well as privacy settings, the option to create a local account. It will be a standard user in this case, but eventually, if it is required, I can also have the end user signing in onto the device for the first time and provisioning the device as a local administrator, even if we do not recommend using this. And whether this is a pre-provisioning deployment method, in this case, I'm going to select yes. I'm going to leave the language region with the operating system default. And I'm going to configure the keyboard to be automatically, I'm going to set the keyboard to be automatically configured, which is applying to devices that go through the process, the autopilot process, if they are wired connected. And then I'm going to apply a device template name. I'm going to give it autopilot dash serial as a suffix. And I'm going to add the security group, which I've just created. Autopilot workshop. Hit next and hit create. All right, so the profile has been created. Now, let's see what is the process. So what is the flow for OEMs and partners? So the OEM and partners must make sure that they ship devices according to the requirements defined by the TPRO, like the operating system version, the existence, the presence onto the device of the TPM, with the device health attestation in the case of pre-deployment, which is a requirement. And it's also a requirement for autopilot self-deploying mode. So the next step is to register the devices with the Windows Autopilot service on behalf of the customer. So the customer need to acknowledge and allow the OEM or the partner for them to be able to register devices in their Intune tenant. So it's not something that can be done without customer authorization. Sorry. What need to be done next is to register the devices, and OEMs can register devices using APIs, or they can use the manufacturer, so they can type, insert the information using the manufacturer, the model, serial number, Windows product ID. And partners have the same options to register devices using the partner portal, but can also use the PKID as well as use a CSV file containing the hardware hash, similar to the option that we offer in the Microsoft Endpoint Manager. However, this is not the recommended way because it requires capturing this information from each device. It can be more or less manual. Devices can also be, in the case of Windows Autopilot pre-provisioning, can be pre-assigned to a specific user so that the overall end user experience is smoother. So the end user is greeted with his username. The only thing that the username has to do is to type his own password valid for that credentials. And the partner can also add value by executing the pre-provisioning deployment flow. So the part where Windows Autopilot ensure that devices can be pre-cached with all apps and with all policies prior to shipping the device to the end users. And finally, again, the device will then need to be shipped either to the end users or to the school, depending on the device distribution methodology that is going to be used. Now, let's have a look at the partner device registration and how Windows Autopilot pre-provisioning flow executed by the partner works. So this is the partner portal. And the very first step, as I explained earlier, is to establish a relationship between the partner and the customer using the partner center. So the partner search for the customer, send a request, and the customer on the other side is provided with an email, with a message where there is a link inside the email so that the customer can accept and authorize the partner to register devices on his own behalf. After the partner, so all these acknowledgement or this authorization has been successfully carried out, the partner can start selecting the customer. He has a list of customers where that he can register devices for. Then he selects the devices, and here he starts the device registration process. So in this case, the customer has requested that device gets registered with a specific group tag. So select to add a new group, give it a name, and in this case, the partner is going to use a CSV file so that devices gets registered in the Autopilot service in the Intune tenant on behalf of the customer. So once all devices are uploaded, still in the partner center, we can check that devices have been successfully registered, and they are. We can also verify in the customer tenant that the devices have been registered by going to the Endpoint Manager Admin Center. We go to devices, Windows Enrollment, Devices, and check that they have already been registered. So the service syncs every 24 hours, but if you want to speed up the process, you can select sync and then refresh to have the device be shown in the Autopilot service. We can also verify that the object has been created, a device object has been created in the Azure Active Directory tenant. So if we go in the Azure Active Directory portal and select device, we can see that a record, an object has been created. As you can see, enabled is set to no, and this is the expected status for devices registered in the Autopilot service before they are provisioned. We can also verify that inside the group that has been created, all the devices are a member of the security group, so that they will process the Autopilot process profile we assigned to this specific security group. So now we are ready to start provisioning the devices using the Autopilot pre-provisioning workflow. So Windows Autopilot pre-provisioning is ideal for a scenario where devices need to be pre-cached with all the apps and policies. It's mainly meant for one scenario, meaning that devices are assigned to a specific user. So those apps and policy can be targeted to devices. Now, let's see how the Autopilot pre-provisioning flow works. So the UBI, the device boots into UBI or out-of-the-box experience. We press the Windows key 5 times. And after that, a new menu appears. We select pre-provisioning with Windows Autopilot and click Next. And the Windows Autopilot profile that has been previously created and assigned will be downloaded onto the device. So the pre-provisioning flow can actually start. We see that there are 3 distinct phases: the device preparation, which is the phase where the device gets registered in Azure Active Directory and enrolled in the Intune service; the device setup, that will process all the policies and all the apps that have been assigned to the device. And then there is the account setup. In the case the device has been pre-assigned to a specific user, it will pre-cache all the apps and the policies that have been assigned to that specific user. Now the process is complete, and the OEM or reseller or partner part has been completed, and the device can be shipped to the end user. So the last part is the end user flow, where the device is received by the end user or by the school, and the end user has to turn on the device and start the provisioning process for the Windows Autopilot workflow for the end user. So now I'm going to show you the Windows Autopilot user-driven. Actually, this is the same process for the user-driven and for the pre-provisioning mode. Of course, as I said, there is a difference because in the case of Autopilot pre-provisioning, all the apps and all the policies have been pre-cached, while for the user-driven mode, everything has to be downloaded and installed once the user turns on the device and type his own credentials. So again, the device boots into the out-of-the-box experience. It checks for updates. It downloads the Autopilot profile. It is presented with the company branding. It types his username and password. And again, the Autopilot provisioning starts. In this case, it was very fast because we used the pre-provisioning mode. If it was, again, the user-driven mode, it would have taken a little bit more of time. The user sign in when the Autopilot process complete. And as you can see, the device is ready for use with all the apps being installed or eventually coming down, depending on how you configure the enrollment status page. Application starts eventually, like Microsoft Teams. And the device is ready for productive use. Now let's have a look at the last Windows Autopilot option, which is Autopilot self-deploying. Self-deploying is ideal for shared device scenario, which are commonly used in early grades, as well as for kiosk devices. It is used, if it is used with a wired connection, again, as I said before, it provides a zero-touch experience for the IT pros or for the end user, depending on who is turning on the device for the first time. And since it does not require a user authentication to complete the provisioning process, it provides a simplified initial device setup experience for the end user, because they don't have to type a username or take any action. So now let's see the enrollment in practice. Since the device is wired connected, it does not require to select any language or to select any keyboard, because it will take the setting that I've configured in the autopilot profile and start the Windows Autopilot self-deploying mode. Apps and settings are installed, security policies are processed, and once it completes, the user will be able to sign in into his device with his own credentials. Again, all apps are installed, or the settings have been applied, and the device is ready for productive use. Here you can find some useful resources if you want to learn more about Windows Autopilot with Microsoft Endpoint Manager. Now I'm going to discuss about endpoint analytics. So we talked about device enrollment, settings, application management, and we provisioned our devices. We applied whatever is required for the device to be productive for classroom, for the classroom experience. But what about the performance of these devices? What about the quality of the experience that we are delivering to our students and teachers? So it is not uncommon that users, the end user experience is not optimal because, for example, they experience long boot times or they have other issues. So all these issues can be due to a combination of like legacy hardware, software configuration that has been made, and that are not really optimized maybe for the end user experience. Issues caused by changes that have been made over time. So this issue and other user experience problem persist because essentially we don't have a great level of visibility into what is the end user experience. So endpoint analytics aims to improve the user productivity and reduce support costs by providing insight into the end user experience. Organizations don't have standard benchmarks to measure how long a device startup should take, how long a reboot should take, or how long for a user should take to sign in, how long an application should take to run, for example. And it is really hard to measure all those metrics even for us, for IT pros. So endpoint analytics provides with the insight for measuring how devices are performing, and in addition to that, also provides some assistance for identifying if there is any policy or any software or any hardware issue that may be contributing to slowing down the device. Endpoint analytics also provides suggested remediation tasks for common issues that devices might be experiencing. So this allows IT administrators to take actions without disrupting the end user productivity and prior to generating a help desk call. So taking a 1,000-foot view of endpoint analytics as a solution, devices that are managed by Microsoft Endpoint Manager, either it can be Intune, so cloud-only management, or config manager with tenant attached. So those devices send signals and metrics on the boot up time, how long it takes for a user to log in, the time that is needed for group policies eventually to be loaded up. So all these metrics and those signals are sent to Endpoint Analytics. We then provide those analytics to, as I said, to IT pros, to IT administrators, in order to benchmark them against the metrics and the signals from other organizations. But you can also create your own specific benchmarks that mark a specific point in time. So let's see more in details what informations are available and what actions can be taken using Endpoint Analytics. So baseline scores are shown as a chart, and they are there is a built-in baseline which is called all organizations median, which allows you to compare your score to a typical organization. So this is the default baseline. As I said, you can create your own depending on the the metrics that you are expecting your devices to have, and to eventually track the progress or view any regression that might happen over time. When you first open the overview page in Endpoint Analytics, you are presented with a few score charts. There are also information about what affects the score and how to improve the score if needed. Endpoint Analytics score range from 0 to 100. Of course, less or a lower score indicates that there is room for improvement, and the score helps you understand the relative impact of each metric in your environment. The Startup Performance Score helps you understand how long for users takes to sign in on their devices and be productive. Again, the startup score is a number between 0 and 100, and this score is weighted the average between the put score and the sign-in score, which are computed. Of course, there is an average between the two. So the boot score measures the time from power on to sign in. And then the sign-in score takes the metrics of the time until the CPU usage has fallen below 50% for at least 2 seconds after the user has signed in. The per device score helps you identify devices that could be impacting user experience, and reviewing scores per devices may help you find and resolve end user impacting issues. As I said before, a call is made to the help desk. You can also select a device from the device score tab and go into the details for the single device. You can also access the per device score on the user's experience tab, which is available for each device in Endpoint Manager. And when you review your organization reports, you can also display individuals' device score with drilling down into the specific device performances. The application reliability reports provides insight into any potential issue for desktop applications, and it measures all the metrics for the application that are managed by Endpoint Manager and that are impacting the end user productivity. Again, the application reliability is a number between 0 and 100, and the score is calculated between the reliability score for each desktop application that is in your environment. There is also the crash frequency, and the total usage disruption is measured by this report. And the last report that I want to show you is the work from anywhere. So the ability for students and teachers to work from anywhere is really essential for today's habits, today's world. And this report offers insight into how ready your teachers and students' devices are to be productive from anywhere. And you can review the score and how they compare to the baseline that you have previously selected. As you can see, you can use the default one, but you can also compare it with your own custom baseline. Again, there is a number that is shown between 0 and 100. And the Windows metric measure the percentage of devices on a supported version of Windows. The recommended remediation that is provided vary depending on how the devices are managed. And then we have the cloud identity, cloud management, and cloud provisioning that they all measure different metrics that, again, provides you visibility into how those devices on your devices are ready to work from anywhere and be really productive to work from anywhere. For all the reports, you can create, you can apply different filters. You can apply one or more filters to discover the different trends in your environment, or to spot any potential issue that might be affecting a specific type of device, or a specific that meet a specific condition. For instance, in the device performance tab for the startup performance report, you might use a filter to identify devices with a high time to responsive desktop, which is measured in seconds, and define the value that this filter must filter for, so that you see only certain devices that are performing in a specific way. So the last part, which is what Endpoint Analytics offers you to take actions, is proactive remediations. Proactive remediations are script packages that can detect and can fix common support issues on a user device before they, and that's the really the meaning of proactive remediation, before they are even experienced by the end users. So each script package consists of a detection script, and then there is a remediation script and some metadata. So through Intune, you can deploy these script packages and see reports on their effectiveness. So you see devices that have been detected having the issue that you are checking for with a specific script, which ones have been fixed, and some additional information. So there are built-in script packages that you can use to get started with proactive remediation. The one is the update, the restart click to run Office click to run service that detect whether the click to run service is stopped and eventually restart it. And the other one is the update stale group policies that check for group policies that are stale and eventually update the group policy engine, start the group policy engine to start processing policies again. The proactive remediation part of Endpoint Analytics leverages the Microsoft Intune management extension, as we have seen for Win32 apps, and devices get rerun the script every 24 hours. So here you can find some useful resources if you want to learn more about Endpoint Analytics with Endpoint Manager. Now let's move into Endpoint Manager reporting. So reports in Endpoint Manager are organized in 4 areas. One is the operational, that is typically used by helpdesk and IT pros. Organizational reports that provide a reporting view of an aggregated view of data which are usually used by IT managers. Then we have historical data, and we have also specialist data, so that you can eventually import data from the Intune service and use logs analytics and Azure workbooks to create your own custom queries and create your own custom reports. So the reporting framework provides a consistent and comprehensive reporting experience. You can search and sort, you can do data paging, and you can quickly generate and view reports created even from large tenants. One additional functionality that is available for reports is that you can export them you can export as a CSV file. One additional option is the Intune Data Warehouse that allows you to access more information about your Intune environment than what is available in the Intune console. And with the Intune Data Warehouse, so you can access historical data. Data is refreshed on a daily cadence, and it uses OData, the OData standard as a data model, so you can access the Intune Data Warehouse using any data client like Power BI. I'm going to show you a little quick because I think we are short with the time. We have different reports in the Intune Admin Center. Under Monitor, here we have a number of reports. Some of them, as you can see, I told you before that you can search and sort and so on and so forth, but those are reports that are still from the old framework. So over time, we are migrating all the reports to the new reporting framework. So for example, with this one, you will see a different view. You can search, you can add filter. For example, the feature update, failures. This doesn't show anything because I don't have much devices into this test tenant, but under reports, for example, we have additional reports like the device compliance. You can refresh, and then we have specific reports that you can look at for device compliance, device configuration, and a number of other policies, other reports. Over time, we will be adding reports into this report plate. Right, so here, the last thing we are going to discuss is remote action. So by using the Endpoint Manager, you can restart, you can factory reset, you can autopilot reset, which is a specific type of reset where all user data gets removed, but the device stays enrolled in the Intune service. You can sync the device so that you can speed up the policy and apps processing onto the device. You can rename, you can delete, you can locate, and also update the cellular data plan. A specific mention must be made to remote log collection, which is very useful if you want to collect Windows devices logs without touching the end user device, so without interrupting the user. So you can use the remote action to remotely collect logs. Non-personal information is collected. Of course, the device must be online, and data is retained for 28 days. And you can collect up to 10 devices at a time. So here you can find additional information that you might find useful regarding all what we discussed so far.